Mr. Schellenberger, just 10 years ago, the idea that the United States would be a net exporter of oil and gas was almost unthinkable. And I think the last time we did that perhaps was about the time of my birth. And I would note to you, my grandchildren believe that's a very long time ago. Then the shale revolution came along, led by federal investments in basic research. American industry made it a reality. And I've seen firsthand in my home state of Oklahoma how it all started with research and development at DOE's national labs, followed by tax credits, market reforms, partnerships that led to private investment and innovation. Today, we're reducing emissions around the world with cleaner, more efficient American natural gas. Now, that said, it's my hope that nuclear power can follow the same pathway and contribute clean, reliable power around the world. Where are we as a nation in advanced nuclear development, and how can we kickstart nuclear energy in the same manner as the shale revolution?
Thank you very much for that question. I actually did a significant amount of research on the historical origins of the shale revolution. And while there's a number of similarities, there's important differences as well. Obviously, you know, the biggest one with nuclear is just that it is a dual-use technology. And so the main obstacle to nuclear's expansion has always been the fears of its use to make weapons. And that's the main reason that I think most progressives and Democrats are concerned about it. That was the nature of my opposition to nuclear as a young man. I think where it's similar is that the shale revolution occurred in the context of significant demand for natural gas. Natural gas has always been viewed as a superior fuel to coal just because of it burning much cleaner. It has half the carbon intensity of coal burning. So there was always a significant amount of demand for natural gas. We don't have that same demand for nuclear just because it's significantly less popular. I think the other big difference then is that when you look at what's actually succeeded for nuclear, both in the United States historically and with what Russia and China are doing now, is that you have heads of state directly selling nuclear power plants to other heads of state. It's a highly centralized activity. You have a single one or two firms. In the United States, it was General Electric and Westinghouse. In China and Russia right now, it's a single state-owned firm. If somebody calls up the Department of Energy in the United States and says, I want to build an AP1000, which are the reactors that we're building at Vogtle in Georgia, there's really not anybody. You would think it would be Bechtel, but Bechtel is only involved in that Vogtle project. They're not actively selling nuclear. So I think we've overemphasized the different nuclear technology designs, which just comes from a community that's very technically oriented. But what makes nuclear successful is when it's really embraced and pushed by both the White House and Congress. And we've got to be building nuclear power plants in the United States, or we're simply not going to be competitive abroad.
Expand just a little bit more on the concept about the anti-nuclear sentiment, which really first, I guess, came around in the 1960s and remains today. Can you talk about what's driving that fear and how the relationship to the broader discussion of some of the predictions about climate change, how all this interacts?
Nuclear is special. So we sometimes say we need all these different solutions for climate change, carbon capture and storage, solar, wind, and nuclear. But nuclear is unlike the rest of those. This is a radical technological, revolutionary technological development, both in the dual nature of the technology, the incredible energy density of it. And I think that really I think the whole human race suffered a kind of trauma and shock when we invented the bomb in the 1940s. And then there was a lot of enthusiasm after Atoms for Peace in 1953 that we would sort of redeem ourselves for having invented such a horrible weapon with nuclear energy. So there's a lot of enthusiasm in the 50s. But ultimately what happened is that the fears of nuclear weapons transferred themselves, just to use a bit of psychological jargon, onto power plants, and anti-nuclear weapons activists somehow imagined that shutting down nuclear power plants would rid the world of nuclear weapons. That's really never gone away. In fact, the apocalyptic concerns that we see around climate change today began with apocalyptic concerns around nuclear weapons. And as the Cold War ended, really the people that were looking for some kind of secular apocalypse found it with climate change, which is why I think so much of the climate activists and environmentalist community is opposed to nuclear. So I think the only way to overcome, I think the main, when you kind of get, I think, to the chairwoman's question, what is the main obstacle to significant accelerated decarbonization? It's getting over our fear of this technology. Nuclear energy is our true blessing. It emits almost zero air and water pollution. In my view, it's the only true replacement of fossil fuels. Renewables are just too energy dilute and intermittent to be able to do that. So we need some kind of a shift in consciousness, and I think congressional leadership and White House leadership is really important to that.
Thank you, Mr. Schiller. And Chair, as I yield back, in an indirect way, I appreciate the endorsement of the panel about the conservation provisions in the 2014 and 2018 Farm Bill. After all, we've worked since 1935 on the land use questions to try and preserve our resources. Yield back, Madam Chair.
Thank you very much. Mr.